mean, she posted it first day. Or like one of these. Yeah. Yeah, yeah, that's
if it'll show up. Yay. Okay. One of the things I'd like to mention, most of you found out about it in the lab, but one of the things in our talking to the um, TFT display is that SPI by default is at about 40 meg. Depending on the screen that you have, it will you're about 20 meg on some of the screens. You might get, I haven't checked on, actually I think the little screen that you have as well runs at about 20 meg. The serial protocol interface can do high-speed serial data, and depends on what your device is that you're going to be able to talk to it at. If you look at the interface chip that's on, I think it's a lot slower. And what you can do is you can go over to SPI and you can adjust that and see, you know, what kind of speed. And it all depends on if the interface chip, and we can go look at the data sheet on the ILI 9341, and it'll say kind of what speeds it should be able to take. But if I crank that up, then you'll see just a white screen. Hopefully, at 21 meg, you'll see something it start to draw. So that was by default. Again, it was at 40 meg, so it was giving us a problem over there. The other times, and I'll just see if I'm actually able to program this. Other times, you might want to be able to slow it down. For instance, if something was going wrong and I wasn't sure what was happening, or wasn't sure if the chip was getting what I thought I would be getting, you could slow it right down and it would redraw the screen way, way slower, but it would maybe give you an opportunity to put those lines on a logic analyzer, for instance, and see what's going on with your clock and your data and things. And you all have a logic analyzer, and we're going to look at it when we get into doing a serial communications one, and we're actually going to fire it up and have a look at some of the data and some of the decoding coming up on that. Don't know if I've got my LCD wired in properly or something, because I think it's giving me an issue. What's going on here? I should have written down. It may not be plug it in properly. Yeah, not really sure why it's. So if you go over, for some reason it's not showing up online right now. If you go over and you just change this and do a divide by like 256, get it to like 328 kilobits or something, reprogram your screen, and you'll see it slowly go down and draw the screen. And then go back. It'll first draw the black when you do GUI in it, and then you'll go to, let's say, the color, the background color, and then you say, as soon as you go GUI clear, it'll start to slowly draw it, painfully so. But that's saying it's at 328 kilobits, and we're doing the 320 by 240 by the three colors, and all that information has to go out to the screen. So you can check that, and then again, when we get it, you do a divide by 4, and that will draw it nice and fast. It's kind of cool watching it slowly paint the screen. Okay, I want to talk a little bit about things that we had the other day. We were trying to talk about some of the different development environments, and we looked at all the different environments that ST gives you, and they have their Cube IDE, and then they still have their Cube MX, and Cube IDE they bought a Tolic, and they integrated it into one platform, and they called it Cube IDE. They still have Cube MX around, which they used to just have 2 separate ones, and then you would do all your code generation and then use a Tolic, which is an Eclipse-based product, to point to the same directory, and you generate code, and then you wait for a Tolic, and the screen kind of flashes a little bit, and then your code's all updated, and then you can do stuff in it. So if you still wanted to go a Tolic, they haven't updated that software anymore. It's all integrated in Cube IDE. But you could use Kyle. You could use something called System Workbench, which is open source and by a company called AC6, which is another Eclipse-based one. And if you didn't want to have to generate all of the structures and then call a GUI init or call the init functions, then what you would do is you would use CubeMX, which is being installed in the lab, but it can't compile. It just generates the source code. And then you point Kyle or AC6 or one of these other development environments at the generated code and use it to compile it. So they've given you choices. Kyle is by the ARM people have that. And so if you look at Kyle, anytime they say just request a quote for prices, it's kind of expensive, but it's a professional system here, just like a Tolic was, but by ARM itself. And so there are whole groups of industries that have all their code based on Kyle. So if you went into one of those companies, then you'd have to get to know the tool set here. You could still generate stuff with CubeMX and then go over and compile it. So that's one of the other ones that are there. The other, let me see if I've got it here. There. Just one of the top, first one on the list I wanted to show you. One of the other companies that makes Cortex microcontrollers, LTC Expresso, has an IDE. It's very similar to, it's an Eclipse-based tool. Again, they take their compiler and their development tools and they make it for microcontrollers. So very similar environment, but that's all for the LPC Espresso. So that's NXP has a whole line of Cortex microcontrollers, similar kind of environment that you can use. You can't use the Cube MX IDE. That's all for ST, kind of products as far as that goes. And then IAR is another one. And so, one of the things about this, and they all used to be like this really before, ST bought ARM, IAR Embedded Workbench. You have a full-on version for 14 days, and then you would either have to get some sort of license, but you can have 12K of code. So if you go and compile, you have 1 meg of flash, but you can have 12K in the environment for that. But again, there's a number of companies that use the IAR system, and you can download trial versions and get to see what you think about some of the environments. Pretty much for anything that you're going to do, or in a small company, the Atomic gives you what used to cost a lot of money for free, so it's a good one to use. But if you saw another chip from another company, then you might not have that option available. So, there's a bunch of modules that are available from like Freescale and a number of companies that are give you the maybe Bluetooth on board. ST has some like that too, but Wi-Fi, ST doesn't have, well, they do, but I'll talk about those kind of coming up, but not the same kind of way. And so you might want a chip from another company that has it more integrated, in which case you'd have to look at another IDE. Again, we talked about Sager, and we're using their graphical library, and so Sager also has a complete IDE available as well. And so again, you might find companies that are going to be using that. So, but if you're looking at Embedded Studio for the Cortex M series, your $2,000, $1,850 US for something like that. One of the, I gotta log in. I wonder if it'll let me log in. One of the ones that's kind of interesting to use is Mbed. And when we first went to look at ARM, I was looking at Mbed, but Mbed at the time, and again from ARM, was a development environment that was just in the cloud. So it was kind of neat in that if I bought an Mbed compatible chip, and there was one from NXP, then it was one of the first ones to come up and just look like a drive. So ST has it with their ST Link. It looks like a drive. I can drop a binary file in and it programs it. Well, Mbed first had that kind of thing to say, hey, here's a new kind of bootloader, just look like a drive. So their whole C++ development environment was in the cloud. And so you log on and you have all your projects in the cloud. You could use just a Chromebook, for instance, do all the compiling, and then when it was finished, it would pop up and say, where do I download it? And you download it to your drive, which is your ARM chip, and then it goes and downloads and programs your ARM chip, and then you have your environment. So it was kind of cool, and you can do that. Some of them say Mbed enabled now, and any of the ones that are Mbed enabled have that USB kind of bootloader kind of thing. The disadvantage of it online was that debugging was non-existent, and so programmers were saying, hey, if I wanted no debugging, I would go and use something like the Arduinos and things, because you can put print statements and that's kind of it. Whereas when you had it here, you want to be able to set up breakpoints and look at watches and be able to look at your variables as things are running. So they came up with Mbed Studio, and Mbed Studio lets you take your cloud, your whole cloud-based stuff and download it onto your computer and have the full debugging capabilities. You don't have to do that. You can do stuff still in the cloud. One of the other things about the cloud interface that I was always a little bit frustrated with was it's a very flat file. You can't, all your projects are just there. And so if you've been working on it a while and you have different, um, you're working with different boards and all the rest, there's no way of putting them into categories, so all of a sudden it gets big and unwieldy. So Embed Studio will let you do that kind of thing as well. But it is kind of interesting. Let's hide this message. So here's the development environment for Embed Studio. Any of the ones like this, have any of you run Visual Studio Code ever before? You ever seen Visual? Any of the Embed, you know, ones, the first thing that comes to mind is a Visual Studio Code. And I think both of them came from the same kind of root kind of area. So it has that kind of an interface. You can download all the libraries. It goes and talks to the cloud. When you plug things in, it will automatically, you know, see your target board and things, and it is not everything is there yet that's recognized in the cloud. One of the nice things about the cloud interface as well is people made libraries. Let's say for your ILI 9341, well, there's a library, and you can say import it into your project, and they have what they call cookbooks of things that people have interfaced, I squared C, SPI, you know, A to D's, all of this kind of thing. And you can use things that other people have put up. And so I wonder if I can see that. Should let me, thought it was going to automatically let me go in, but somehow. Might have to. I'd have to go figure out which one, what my password is. When you look at whether it's AC6 or the LPC Expresso or the Atolic interface that's integrated into CubeIDE, they're all based on Eclipse. And Eclipse, you can go down and download Eclipse IDE just from the web. And there's all sorts of plugins. So what's happened is Atolic or LPC Express or what have taken Eclipse, downloaded it, it's open source and it's free for anybody to use. And then they have integrated their tools into it, just like you could. And so if I'm a new manufacturer and I want to C or C++ or Python or whatever development environment, I could start off with Eclipse and then tailor it to talk to my tools. And so that's what they give you there. So if you, for instance, wanted something on the desktop, you could download Eclipse, and they have plugins for C and C++ and Python and JavaScript and all sorts of things. So you could just put all those tools and just develop desktop things. The value added that some of the different companies give you is they put in their tools to be able to do advanced debugging. Maybe they have nice library support for all the different peripherals for the embedded devices and things like that. And that's why you pay a bunch of money for some of these, or again, in the case of the CubeIDE, it's all in there. But very familiar look and feel if you're using any of those kind of tools. If you're using the Embed one, any of the looking at the Embed one online is very, very different, kind of old kind of school. And if you're looking at the Embed development environment, it's very Visual Studio Code-like. Which, incidentally, if you've used Visual Studio Code, you can use Visual Studio Code to talk to Arduinos and use the Arduino interface. And so you have to have the Arduino interface installed, but then Visual Studio Code, very much like Eclipse, would go and call, it goes and calls the Arduino interface, but gives you the ability, if you're using other boards, to do debugging and things. Yeah? Sorry, you can do the same thing with it? With Visual Studio Code when it comes to STM32 as well. Oh, yeah. So, well, yeah, and you can code, are you talking coding with the Arduino interface? No, using the platform Oh, yeah, yeah, so there's plugins or extensions like platform.io, which then gives you the Visual Studio Code interface, yeah, and then gives you all sorts of nice features tailored to STM or tailored to, and we're going to talk coming up. I'll have you use your STM board, but use it in the Arduino kind of sketch interface, and you can use that. And so we're also going to use it with your Node MCUs. We're just going to use the Arduino interface, but you can for sure use the platform.io as well. And so one of the things that's really nice is using that familiar interface is being able to then install the whole tool suite for compiling and linking different processors. The actual Atmel AVR was designed quite a long time ago, and since then the C compilers have come a long way, the debugging features have come a long way, and uh, the silicone wasn't designed with those advanced debugging features in mind on the AVR. But if you want, like your Arduino interface, and want to use something else, we can plug in, for instance, the whole ST board, and you just have to, there's a section called board extensions, and we will do this with the Node MCU, and you can download the development tools for ARM or for ESP8266s or for a number of other things, and then a lot of the libraries that you have been used to in the Arduino are all of a sudden now available for your ARM board or for your ESP8266 board or for some of that. That's one of the things that when we start talking about the Node MCU or the ESP8266 that you have, that originally was a little chip that had a Chinese documentation that appeared on the web, and people went, "What is this thing?" And it was originally designed as a kind of a Wi-Fi for other people's chips. And then somebody figured out that, oh, it's also got a processor inside, and you can actually program it by itself. And it was didn't really do too much. And then somebody got it, the tool suite ported over to the Arduino interface, and all of a sudden the hobbyist market took it and it went everywhere. So the little chips that we're going to be using in a few weeks, the Node MCUs, the little board by itself is probably, with the USB debugging interface, is probably $12. Just the little chip by itself, it could be got for about $3, and it gives you Wi-Fi, and it gives you a microcontroller, and you can, if you open up, you know, Wi-Fi plugs or switches that you got from, let's say, Costco or something like that, or probably Home Depot, there's probably one of those chips in it, and you can program them. And the interface will be either in the sketch interface or something like that. So Eclipse, all of these, a lot of these ones that I've been talking about, we either have a Visual Studio Code kind of interface, or we have an Eclipse-based interface. There are others, NetBeans, for instance. The MP Lab, when you've used it with Wayne, is based on the thing called NetBeans, which again you can download and you can put your own tools in it. You can put all of these tools into it if you so wish. Some companies base it. Microchip changed over from their own supporting the whole IDE themselves to basing their stuff off of NetBeans. And again, if you like that kind of interface, NetBeans has C compiler, C++, all of that available as part of their tool suite as well with the development environment. Before the Atomic interface with ST and things, or there's an open STM32 community, and they gave you a system workbench, it's called, and it's the company's AC6. And again, Eclipse backend, you generate stuff with CubeMX, and then you import it into the AC6 environment. It has all of the debugging features and things that you would get as well. And we used to have to run this. I would go, like ST, they still frustrate me sometimes with some of this stuff. ST integrates some stuff And then they'll have all sorts of other teams developing things they have great motor controllers and all sorts of things. And they make these projects that you can then open up and run and get a motor spinning, but then you want to add an A to D or you want to do something else. And they don't have the .ioc file that lets you open up the graphical environment because it was a different team and they haven't been using that or they haven't got there yet. And so when I was at one of the ST conferences, I was going, frustrated because, you say, hey, use the Cube IDE for everything, and yet there's a lot of packages that you still are coming out with that aren't integrated into it yet, and it's like, it's a big company, and they're trying to integrate the teams to have it more unified, and it's gotten way better. When the Cube IDE first came out for about 2 years, I would look at it and it was so frustrating and things didn't work and we couldn't do what we needed to do that we used CubeMX and we used Atolic by itself. And we did that for a while. And finally, the IDE got to the point where it was more seamlessly integrated and you don't even think, you just go to your IOC file and then you go over to your header file and things are working. So anyway, AC6 is another one that you can use. Okay, so an Embed Studio. I wonder if I have Embed Studios. I don't know if I have it installed here. Embed. No, it's on. One of the nice things about some of these ones is, for instance, the Embed, for instance, you can run on multiple platforms. And again, you can run it straight in the cloud. And so without the debugging features. Let's have a look if let me do it here. And of course it's asking, it's not liking me logging in. Okay, so we talked to AC6, and of course the thing about the STs and the system workbench, the CubeMX just by itself, if it says CubeMX, and by default the guys in the back room had installed that on the machines. CubeMX generates the code, doesn't have the compiler in it. CubeMX IDE generates the code, everything CubeMX does, but you then have to have another thing like AC6 or Atolic or Kyle or something to go and import it. And one of the tools that's in your development environment, when you go over to, we go over to Project Manager, and it says, hey, what's the tool chain? So it's saying here, and there's something, I wonder if it's letting me. So right in Project Manager, it lets you drop down and say, do you have IAR? Do you have Atolic, just standalone by itself? Do you have the Cube IE? And it knows where all of the different things are and what directories they go in to be able to go and stick those in place. And again, we also have the Arduino plugins. And so if you want the Arduino interface, let me just go to Arduino interface, PC, see, users. And so, when you used the Arduino, when you downloaded it, did you download just the zip file? You didn't download the Windows install, like way back when you did Arduino. Hopefully Phil, was it Phil? Told you to just download the zip file, did he? Or did you just install it? Hard to say. Okay. When you go over to the Arduino interface, it'll say, hey, download, I think you can download it in the Windows Store. You can download it just for MSI, just to install system-wide, or you download portable, just a zip file. You always want to download a portable just for a zip file. You see, I have Arduino 1.8 for an ESP8266. I have Arduino for ST boards. I have Arduino, the normal one, for Uno boards. So I've unzipped each one. And then what I've done is I've made a portable directory. Did he ever tell you about making a portable directory? Before you open it up, when you download it, you make a portable directory. And the reason for that is then it says instead of putting stuff in my system folder, which is the hidden app data folder in Windows, instead of burying a bunch of stuff in there, stick it in there. And so it makes it portable. You could actually take that whole Arduino 1.6 folder with your development tools, everything, stuck in there, put it on a USB stick, take it home, for instance, and you have all of the stuff. You have all of the libraries that you installed that go with it. Everything goes into portable. And so what I have then is I've got a bunch of different versions of the Arduino, but I wanted to set it separate for which libraries that go with which processor. And so Arduino 1.6 here, if I just click it, and then I go in here and open it up. If I look at inside portable, it was an empty directory before I started it up. But if I go into Sketchbook, for instance, there's the libraries that I'm using in there under ST, and then there's all the packages and libraries and things that are there. If it's, has it opened up yet? Oh, it's taking its time. Okay, so in here, when I go File, Preferences, there's this board manager. And it's got just a link to a website with a JSON interface that will download all the different boards that it supports. And then when you go into libraries, it will load up all the different things. So if I look just at this one, I've said it's my ST microelectronics package. If you look at tools, a board, there is the ST boards. There's all the different ST boards. There's generic F4s, there's discovery boards. So if I've clicked on discovery board, then it says, oh, which discovery board do you want? And it knows about all the different boards. So all of the different things you're used to with the writing to the D7 to D0 and all of that kind of stuff, those all work now, but you're using it on the ST's environment. So some of the libraries for ILI 9341s, those are all available to you. The one trick with some of this, with the different boards, because if I open up the one for the ESP8266, it'll show me the different boards that are available for the ESP8266. That's kind of why I've kind of kept them all separate. It has a bunch of other features there, and I'll talk about some of those when we go and look at some of this stuff. But it gives you all of the options and settings for there. Now, one of the things that's sometimes tricky to go find, for instance, is if I do a digital write to D7, I don't exactly know where that is. Because what is D7? I know on the UNO it's marked on D7, but you might have to go look in the header files to say, oh, that might be GPIO port B7 or B0 or something like that. You don't know. Necessarily. Hopefully the documentation would show you. But you then have to go and look in the appropriate header files to see what it is. The advantage of some of this, and why we're talking about any of this kind of thing, is we're looking at ST parts, and we're looking at ST's development environment that they have offered us, which is the Cube IDE. But there's other things they offer, like CubeMX, to use other environments like Kyle or IAR or AC6 or a number of those. And when you go into the IDE and you go into our board manager, I wonder if it'll let me do it now because it was all grayed out. It's still grayed out, don't know why. It will give you the option for all of those different tool suites. But then you can say, oh, okay, I don't want to do that. I want to have a look at some of the other things that are available. And if Mbed, which is a full C++ compiler, all their libraries are in C++, is available on cloud or in a Visual Studio Code-like environment. And again, has support for all your boards here. You can then go and say, hey, I want to use something like the old Arduino interface, and I have a number of students that to get the project, they want to use an UNO. One of the things that can be a problem with an UNO, in fact, I saw it this week, project group was using the little LCD that you guys have. So not this one, but the little one that you have from Wayne's Court. So they're going to use one of those. But it's a 3-volt display. So they're having a bunch of resistors to divide down 5 volts to 3 volts and all the rest. Well, you could just pick a little ARM board and use the UNO interface if that's what you're most comfortable with, and find out where D0 to D7 is, and then you're at 3 volts. Okay, you have far more memory than you do on the AVR. You're running at 180 megahertz instead of 16 megahertz, so you have a lot more speed and all of that kind of thing available. So there's all of these different options available to you. And sometimes, and I mentioned also the LPC Espresso Eclipse environment, because you may look and see that a solution isn't available in the chips, maybe that one manufacturer has, and you might want to look at another manufacturer. So NXP has the same libraries for TFT that ST does. So you may look at that ID interface and use kind of those tools. Some of the tools give you limited 12K or 30K of code, and then you'd have to pay for a license for some. And that's what's nice about like the AC6 or the Arduino interface or the Atollix and things like that. Long and short is there's lots of different development environments. There's lots of different choices. If something is not working, oftentimes the reason the Arduino interface is picked off because it's a big hobby community. Lots of libraries have been there, and you might find a library that is there that isn't necessarily over in ST's interface. So you might go, oh, I either have to write that myself or go about porting it, or just use a different development environment that already has the stuff I want to do. Okay, so that can save you a lot of time, especially if you get to project, for instance, and we have 14 weeks to do something, and you can't spend 3 weeks wasting your time or porting something. Just pick a different development environment that supports what you need to do. Okay, we'll leave it there for today. Thanks. Good luck on your test today.